In this video, we will use the properties of parallelograms to help us prove triangles are congruent, as well as specific parts. So what are these properties of parallelograms? Well, let's start with the definition of a parallelogram. A parallelogram is a quadrilateral whose opposite sides are parallel. So that's the definition. Now, in addition to that, we've got these four properties. The opposite sides of a parallelogram are congruent. So that means like this side and this side will be congruent, and this side and this side will be congruent. The opposite angles are congruent, which means that this angle will be congruent to this angle, and this angle will be congruent to this angle. Consecutive angles are supplementary. That means that this angle and this angle will be supplementary. So if I told you that this angle was 100, you would automatically know that this angle was 80 because they have to add up to 180. And finally, the diagonals bisect each other. That means that this piece of the diagonal and this piece of the diagonal will be congruent, and this piece of the diagonal and this piece of the diagonal are congruent. Now let's see how these things play out in a proof. Fact: in Unit 3 we saw that the diagonals of a rectangle are congruent. Let's prove this fact. So we're setting out to prove that the diagonals of a rectangle are congruent. A rectangle is a parallelogram that has four right angles. That information is given. We want to show that the diagonals are congruent, so that's what we're trying to prove. Okay, so let's scroll down. So we're given that this whole quadrilateral is a parallelogram, and we're given that ADC, okay, ADC, that's this angle right here, and BCD, all right, BCD, that's this angle right here. We're given that those are right angles. All right, let's go through this proof. So ABCD is a parallelogram. Obviously, that is given. And then we have AD is congruent to what? Well, AD should be congruent to BC, all right, segment BC, because the opposite sides of a parallelogram are congruent. All right, opposite sides of a parallelogram are congruent. Now, ACD and BCD are right angles. That is given. So ACD is congruent to BCD. Well, we know they are right angles, and we know that right angles are congruent. So right angles are congruent. Now, DC is congruent to DC. Well, of course, that's going to be the reflexive property. All right, anytime you see an angle or segment congruent to itself, you know that's going to be the reflexive property. But let's take a look at that in the picture. So here's DC, so of course that's going to be congruent to itself. All right, now, you might be thinking, because of your experiences with the reflexive property, normally the way the reflexive property shows up is that we'll have maybe one triangle like this, and then we'll have another triangle like this, okay, and then we will talk about the shared side, and then that's the reflexive property. Now this is similar, but it is a little bit different. I don't want you to be thrown by it. So understand this. The two triangles that we are looking at, we have one triangle that's like this, Okay, and you can see the right angle right here. Okay, and then, but the other triangle is like this. You know what, let me do this in green. All right, here is the other triangle. And there's the right angle. So if you look at it this way, hopefully you can see that DC is a shared side. All right, there's a green DC and there's a red DC. That is an overlapping side, even though it's a little bit different from what we're used to. Okay, so that's why the reflexive property is showing up this way. Now, triangle ACD, okay, ACD, that's the red triangle, is going to be congruent to the green triangle. Okay, so let's be careful. ACD, that's going to have to be BDC. All right, the order is important. When I did the order just now, notice that AC is the hypotenuse. So I made sure that I did the hypotenuse first. All right, AC, and then I went BD. I did the hypotenuse first. Okay, so let's look back and see, why do we know that these triangles are congruent? Well, look at the green triangle, for example. See how we have a side, an angle, and a side. We have two sides and the angle in the middle. And that's the same for both triangles. We have two sides and the angle in the middle. So these triangles are congruent by side, angle, side. Now that we know that the whole triangles are congruent, any corresponding parts will also be congruent, because corresponding parts of congruent triangles are congruent. So we've proven that the whole triangles are congruent. The red triangle is congruent to the green triangle. So now I can say that the hypotenuse of the one is congruent to the hypotenuse of the other, because these would be corresponding parts of congruent triangles. And that's it. We proved that the diagonals are congruent. Fact: every isosceles triangle has two congruent sides, and it also has two congruent angles. Let's prove that by having two congruent sides on a triangle. Let's prove that having two congruent sides on a triangle guarantees two congruent angles. We begin by drawing a new segment GF, which is the dashed segment below. So we're given that the whole triangle is isosceles with EG congruent to HG. All right, so we're given that this is congruent to this. We are given that F is the midpoint of EH. Now notice that this is going to take up two lines on the proof. All right, this is not a congruent statement, so this is indirect. So first we'll have to take one line that says F is the midpoint, stating the given, and then it will take a second line to say that that means this piece is congruent to this piece by the definition of midpoint. So this is going to be two lines. Okay, and ultimately we want to prove that angle E is congruent to angle H. Okay, so let's go through this proof and see what we've got. So basically we're given EG is congruent to HG. All right, we've marked that, that was given. All right, F is the midpoint. Now that was not a congruency statement, so I need a second line where I will say that therefore EF is congruent to FH. Okay, now that is the definition of midpoint. Now for some reason on a quiz that we had recently, I had a bunch of students I mean, obviously it wasn't filled in for you, but I had a bunch of students wanting to say definition of segment bisector. So let me just emphasize that this is always going to be connected to this. All right? If this statement says midpoint, then it's going to be definition of midpoint. If this statement says something about a bisector, then it's going to be definition of segment bisector or angle bisector. All right? These have to match. So never look at midpoint and then say segment bisector. All right? They are closely related, but they are not the same thing. So anyway, moving on. Then now we have reflexive property. So you can probably guess that I'm about to do this. Boom, boom, boom. Obviously, this GF is shared by both triangles. So I get to say that GF is congruent to GF. Okay, that's the reflexive property. Now the order matters when I say that the triangles are congruent. So EGF is congruent to HGF. Okay, and that's going to be by the side, side, side postulate, because you can see 3 congruent sides marked. Now that we have proven that the triangles are congruent, any corresponding parts will be congruent, including E and H. These are corresponding parts of congruent triangles. So we know that corresponding parts of congruent triangles are congruent. And there we proved it. Okay, fact, on any rhombus, by the way, a rhombus is a quadrilateral with 4 equal sides, like a square, but it doesn't have to have 90-degree angles. The diagonals bisect the angles of the rhombus. All right, so on a rhombus, a diagonal is going to be an angle bisector. A rhombus is a parallelogram with 4 congruent sides. On the rhombus below, we have drawn a diagonal as a dashed segment. Let's prove that the diagonal NL bisects angle KNM. Okay, that's this angle in the lower left-hand corner. Let's prove that this diagonal is an angle bisector. Okay. So here we go. We're given that it's a parallelogram. We're given that KL is congruent to ML. Okay, so KL is congruent to ML. All right, that's part of the definition of a rhombus. We know that KN is going to be congruent to MN. Okay, so we have that. So let's go through this proof and see why NL has to be a bisector of this lower angle here. Let's see. So the given is all listed here. Now they mention the reflexive property. Can you guess what I'm going to put right here? Okay, I'm going to mention the shared side, NL. Okay, so NL is congruent to NL. All right, because that's how the reflexive property works. Now it's time to say that the triangles are congruent. So be careful of the order. Okay, KLN. Okay, so KLN. So now I'm going to go MLN. All right, the order matters. Now why? This is going to be the side, side, side postulate. All right, you see all 3 sides marked congruent. Now I see that CPCTC, corresponding parts of congruent triangles are congruent. That means there must be some corresponding parts that we're supposed to say are congruent right now. Well, if our goal is to show that this angle is being bisected, then that would mean that each side of this angle is congruent. So those must be the corresponding parts that we need. So for example, angle KNL, all right, that would be the top half, all right, angle KNL is congruent to angle MNL, all right, that would be the bottom half. Angle MNL. Okay, because these are now corresponding parts of congruent triangles. CPCTC. So that leads us to be able to say that NL bisects this angle, because that's the definition of angle bisector, is that you're splitting the angle into two congruent parts. So NL does bisect angle KNM by the definition of angle bisector. Fact, on any rhombus, drawing the two diagonals will create four congruent triangles. A rhombus is a parallelogram with four congruent sides. This information is given below. Prove that there are at least two congruent triangles, the green and the blue. Okay, so we're given that the whole thing is a parallelogram, and we are given that KL is congruent to ML. Okay, so KL is congruent to ML. Okay, so KLMN is a parallelogram that is given. KL is congruent to ML, that is given. LN bisects KLM. Let's see, here's KLM, and LN is this angle right here. Okay, and we're using the property, the diagonals of a rhombus bisect the angles. We can use this because we just proved it in the previous problem. So now we're using that as a postulate. Okay, so so now we know that LN is the angle bisector. Okay, so that means that what is going to be congruent to what? Well, if this is the angle bisector, then that means that this angle is going to be congruent to this angle. So that's angle KLN. I could have said KLP, but I'm going to say KLN. Is congruent to angle MLN. Because that's the definition of angle bisector. Okay, again, notice how these match up. If this says bisects, then I'll have definition of bisector, either angle bisector or segment bisector. If this says midpoint, then this would say midpoint. These always match, bisector, bisector, midpoint, midpoint. Never mix the two. Anyway, time for the reflexive property. So looking at the green triangle and the blue triangle, the reflexive property would involve this shared side PL. So I'm going to say side PL is congruent to side PL. Reflexive property. So the triangles are congruent by what property, what postulate? Side, angle, side. I have two sides and the angle between them. So that is side, angle, side. All right, so we have proven that there's at least one pair of congruent triangles. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.